So what does the question say? Given an array nums of integer written the length of longest arithmetic subsequence in nums, note that a subsequence is an array that can be derived from another array by deleting some or no elements without changing the order. So we don't have to change the order. Suppose like we are doing 3, 6, 9, and 12, we're going 1 to the next, to the next, to the next. But we can't read like 6, then 12, then come back to 3, and then back to 9. So we just can't do some form of zigzag movement here or go back and forth. So and the next example exactly does that. It has 9, 4, 7, 2, 10, which is not pretty odd. 4 is less than 9, but again 7 is greater than 4. So the longest arithmetic subsequence is 4, 7, and 10. It's kind of increasing as well, but the increasing thing doesn't apply here because the arithmetic means it has some form of like mathematical subtraction. If you mathematically subtract it, then you get some form of number like 7 minus 4 is 3 and 10 minus 7 is 3. So it follows the principle of arithmetic progression. I guess I'm trying. I haven't done maths question in long. So like it's pretty much the same idea. So how can we do this exactly? Let's come back to drawing. And suppose like while doing this question, we'll store n then of nums and we'll store res as 1 for now. And we'll create a map. We'll creating a map that is we name the map as dp, and the map is going to have how many like it's going to have n values. N values is going to store n values. Suppose there are 4, make 4, but for 4 it's going to be inner map as well. 2 is going to be inner map as well. 3 inner map, so it's going to be 3 or 6 or 9 or 12. And I'm going to tell you why we're going to use this map. So we iterate 0 to n minus 1, which is the very last element, and then we iterate to this is I, simple I iterate to I, and this is j. So the actual name of the variable that's going to be used, iterate to I and j. So what we're going to do now, we're going to find the difference, and the difference is going to be like nums of I plus 1, or we can say that nums of I minus nums of j. Nums of I minus nums of j. Great. The first time it is 3, 6, 9, 12. So we'll do this. 3 minus this 3. Okay, it's 3. So what we are going to do next, we got in the first iteration we got 3, while I is equals to 0, and this is what we are doing computation right now. So we'll do dp of I is 0, dp of 0 of 3, yes 3 is going to be dp of I is 0, dp of def is 3, and dp of j exactly is going to be 1 plus dp of j, and j is currently 1, and the value of like def is 3, differences obviously 3, so 1 plus the difference, so it is default value is 0. Its default value is 0 even if it doesn't exist. We are using like pre-computation dp, but we're using map here, so we can use, you can initialize if it's not present. So the value is 0, so it's going to, so 1's going to be stored here, right? And we will check if uh, answer is greater than 1. So if this is greater than this, no it is not, so rest will remain 1. All right, it will remain 1, and we'll move ahead now to this. move ahead to this. Again, 9 minus 6 is 3, and I'll write it here. I equals to 1. I equals to 1. 9 minus 6, 9 minus 6 is 3. Alright, so we'll iterate from 0 to 0 to, well, j we take value. J start from 0 and I is 2, so we'll consider j as 0 and j as 1. So while j is 0, what we are going to do, uh, we'll compute like this. This is what we done. 9 minus 6, so j is 3, so 9 minus 3, 9 minus 3 6, 9 minus 3 6, and what we are going to do, we'll write dp of I if our I is 1, our j is, and our difference is 6. It's going to be dp of 0, which is our j 0, and exactly like this was the thing here as well. dp of 0 3 is 1, because I was 0. Suppose I was 0, so we neglect that. But if I is equals to 1, yeah, that was the case. Sorry, exactly. So it's going to be 1 here and it's going to be 2 here. So that was one mistake I was doing. So like if I is 1, this will remain 1. So j, yeah, so like I is going to be ahead and j is going to be back. So if I is 1, like I is going to be 1 here, I'll just make it 0, and I'll just erase it to be 1, because I is ahead. I is ahead, and j will be at 0. And again here is well 0, and I will be at 2. So I will be at 2 and j will be 0. 0 of 6 is going to be plus 1, and this is default by default 0, so it remains 1. And then dp of 2, and again for 9 minus 6 it's 3. dp of 2, uh, that is dp of 2 of 3 equals to dp of 0, or like dp of 1 and 3, because 1 is what the value of j is currently. So now we come back to what we stored here, dp of 1 3. So yeah, like it's going to be 1 plus 1 2, exactly 2. So things are working now, at least. And if I just, and if I just place it above everything, and do it for like I equals to 3, I equals to 3, I equals to 3, j, where j is equal to 0 first. And for j, now we will check the value of 3 is 12. 12 minus 3 is 9. So dp of 3 comma 9, 3 comma 9 equals to, what's the value of j? dp of, oh, 0 comma 9 plus 1, it's by default 0, so 1. And dp of, for, I guess what's the problem here, I don't know, like dp of 1, dp of 3 comma 6 equals to dp of 1 comma 6, and like dp of, if it is 3, then we first be like 6. Yeah, so like 12 minus 6 is 6. Yeah, 12 minus 6 is 6. So yeah, it is pretty much correct, and we are going the right way as of now. And so like this plus 1 is going to be 1. So but dp of 2, it's going to be for j equals to 0, dp of 3, which is 12 minus 9, 12 minus 9 for this. dp of 3 comma 3 is dp of 2 comma 3 plus 1, and 2 comma 3 plus 1, which goes from here, which you've already pre-computed 2 comma, and this is 1 comma 3. Please don't be confused, because this is what we found in last time. So the value is 1 plus 1 2 that we found here, and this goes on to be 2 plus 1, and the answer we will return is going to be like 3 6 9 12. So this are 3, but there are actually 4 numbers, so we're going to return 3. And so we'll just return what we obtained here. This is res, all right, and res is going to be a, like, we'll check for max between res and whatever you obtain here, here, here every time. So it's going to be 2 now, then 3 now, and we'll return res plus 1, which is going to be our answer. So let's just code this, and equals to len of nums. Great. uh, res equals to 1. uh, Either you can solve a 2D array consisting of 1001 elements, because that's the constraint, or you can make a default take, which is like pretty handy, lambda. You can go and read through docs if you don't know like what is lambda. It's just a 1 minute thing. You get to know it's nothing serious. Or you can certainly give like a lot of time solving DSA. It's not a big deal. For j in range I. Yeah, that's what we were doing. Def equals to num of I, nums of j, because j is at the back, nums is in front, dp of I def equals to dp of j def plus 1. Great. And after this, res is going to be max of res comma dp of I def. Yeah, that's it. And we'll return res plus 1. Let's see if it works. It should. We've done everything right here. It should work. Yeah, great, it's working.